Good morning. Next section that I want to talk about regarding the 2014 DEI product brochure is the category of voltage controlled oscillators, VCOs. VCOs, unlike a VCXO, VCOs do not use a quartz-based resonator. VCOs use another material for the resonator that's part of the oscillator circuit. A coaxial resonator, a ceramic resonator, but it's not a quartz crystal, an AT cut crystal or an SC cut crystal. Non-crystal based oscillator. These are used in synthesizer circuits as part of the synthesizer loop. We have a standard family platform that we offer customers, 12.7 by 12.7 millimeter surface mount. We can design any VCO a customer needs, from all the way down to 5 megahertz, all the way up to beyond 10 gigahertz. We can even go to a couple different packages, and right now included in the brochure is primarily our standard 12.7 by 12.7 millimeter. And again, case by case basis, we can do different things in different packages in the VCO world. VCOs are very basic in the sense that there are certain trade-offs in performance. One example is if you need a wideband VCO, and what I mean by wideband is if the start frequency is at 1 gigahertz, for example, and the end frequency is at 2 gigahertz, you now have to cover a 2x frequency range relative to the start frequency, 1 to 2 gigahertz. Anything with at least 2x span is considered a wideband VCO. A narrowband VCO has only a very narrow range of frequencies that are used, say from 2.5 gigahertz to 2.6 gigahertz. That is a 100 megahertz span. Those narrowband VCOs, the narrower the frequency range needed, the higher the Q of the oscillator circuit, the better the phase noise. So for narrowband, you have much lower, much superior phase noise performance. For very wideband, you have a degradation of phase noise because now you need a much lower Q circuit in order to generate a much wider frequency range of usage. The tuning voltage is a very critical parameter for the VCO. What voltage range are you going to drive the VCO with in order to get the corresponding frequency range? For a 5 volt supply, a common range is 0.5 volts to 4.5 volts. For an 8 volt supply, it might be 0 to 8 volts. However, for super wideband applications, you might have a 5 volt supply driving the oscillator, but you may need 0 volts to 20 volts on the control voltage coming from a separate source in order to get enough voltage range to cover the frequency range of interest. The tuning voltage sensitivity is another critical parameter of VCOs. The megahertz per volt sensitivity. That particular parameter is a typical value at 25 and at a given mid-range tuning voltage. As you go down to the lower tuning voltages, or as you go up to the higher tuning voltages, that megahertz per volt tuning sensitivity will vary 2, 3, 4 to 1 ratio. The lower the voltages, the higher the tuning sensitivity, the more megahertz per volt. The higher the voltages, the lower the tuning sensitivity, the smaller megahertz per volt. All of that is related to the most critical element in a VCO, and that is the varactor. A varactor's capacitance changes as a function of voltage. It changes in an exponential fashion, so that the slope of the varactor curve is very, very steep for low voltages, and as you get to larger and larger voltages, the slope of the varactor curve is very flat. Therefore, the corresponding reduction in tuning sensitivity. That is always going to be there for VCO applications. The main back and forth compromise with the engineer is going to be how wide a band of frequencies do they need. given what kind of phase noise they need. And there's always a trade-off, a direct trade-off between phase noise, tuning sensitivity, and how wide a frequency band you're going to get. So VCO opportunities, for example, when they use wideband for a microwave application, they might need 4 or 5 gigahertz span to cover the transmit and receive functions of a certain satellite system or microwave communication system. Other customers might only use, say for an industrial application, they might only use a couple discrete frequencies of the VCO. In other words, they might use 2.5 gigahertz, and then they might use another frequency that's 455 kilohertz offset from that. One is for the transmit frequency, one is for the local oscillator. That kind of system, a simple wireless data collection system, will transmit the data of whatever their machine is collecting. They'll transmit the data and they'll use a local oscillator. So they only have a couple discrete frequencies that they use on the VCO over the entire life of the VCO. So those are interesting products to promote. Part of the VCO discussion, as I mentioned in an earlier video training session, involves synthesizers. Synthesizers, of course, incorporate. Remember our RF system block diagram. Synthesizers incorporate the low frequency, highly stable reference, the synthesizer chip, the PLL loop, the VCO part, all of that integrated into a synthesizer that's programmable. We can do synthesizer modules for customers, but again, that requires a more intimate interface with your highest level R&D engineers in your account to understand their system requirements, their RF system requirements, to a much higher level than just say at the TCXO or OCXO level. That will be handled on a case-by-case basis. Thank you very much.